Welcome back to my channel, everyone. Three Tips here, and this is the small gold button that I recovered from my stock pot refining series. I think it was video number 3 or 4. I can't remember. I'll post a link in this video so you can see where this gold came from. We've got 10.6 grams of 24K pure gold, and what we're going to do is a repurification. I've got 10.6 grams of pure gold here, and I want to multiply that by 3. 10.6 times 3, that's going to give us 31.8 grams of silver that we need for this inquartation. Someone had asked about why we multiply this number by 3, and the answer is we want an alloy that's 3 parts silver and base metals and 1 part gold. 4 quarters, 1/4 gold, 3/4 silver and base metals. That's why we multiply by 3. I'm going to multiply this number by 0.95 to reduce the silver just a touch. And so it looks like we want 30.2 grams of silver for the inquartation. Got a sterling silver spoon, and this spoon will be perfect for the inquartation. It weighs, I think it's 30.7. We're looking for 30.2. This should be close enough. This is the 10.6 gram pure gold button that I recovered from my stock pot refining series number 3. And I've added a sterling silver spoon in there. And what we're going to do is we're going to inquart that 99% pure gold button with some sterling silver, and then I'll pour it in water to make granules so that we can pull the sterling silver back out with hot dilute nitric acid. Here it seems counterintuitive to add silver to the gold to purify it, but what will happen is when we pull that silver back out with the nitric acid, other impurities, especially platinum group metals, will be pulled out of the gold with the silver with those nitric acid boils. Well, that was interesting. I forgot to stir it, and so I don't think we got a very good alloy. What I'm going to have to do is dry this off, remelt it, and then stir it with a graphite rod before I pour it in the water. Got everything dried off now. Let's take it back over here to the melt table. What we'll do is just add it right back into the same melt dish and melt it up a second time. This is looking much better. Now we'll get this out of this water and into a beaker. Here's our unquarted gold. People are probably asking, why am I adding silver to it? It was already pure gold. And the answer is, the pure gold was not high purity. It did have some impurities in it. Adding silver to it and then pulling it back out with nitric acid like this does a fantastic job of cleaning this gold up in the first step of the refining process. I could have just dissolved the 10.6 gram pure gold button. It was about 990 purity in aqua regia and refined it that way, but I found through experience that in quartation does a fantastic job of cleaning this gold up. This is my silver jar. It's full of sterling silver. And what we're going to do now is pour off this first nitric boil into this silver jar. This solution I'm pouring off here will be full of silver, so we want to save it. Now what I'll do is add some more nitric acid, dilute nitric acid, and do a second nitric acid boil. The second nitric boil is complete. So now what we're going to do is pour off this boiling nitric acid into our silver jar. Rinse it out real good. Most of the silver is out of there by now. And so what we need to do here is do a final nitric acid boil. And I'm just going to use some distilled water and some fresh nitric acid and let this boil. This is the third and final nitric acid boil. It's been on there boiling for a couple hours. And as you can see by the color of the solution, we've put a little bit of the gold in solution with the boiling nitric acid. What we'll do is I'm going to pour this off now and we'll save it for a future refining. Next, I rinse it off with a little distilled water, and I'll add that distilled water rinse to the silver jar because it may contain a little bit of nitric. And then we're going to put it back up on the heat and boil the gold for just a little while in some distilled water. I've had this on lightly boiling in water. I've run out of room back here in my silver jar, so we're just going to pour it into this auxiliary silver jar that I have down here. Rinse it with a little bit of distilled water. I'm going to add hydrochloric acid to the gold now. Set it up here in the heat. Sulfuric acid. Add a little bit to precipitate out any lead that may be present. Now we'll add some nitric acid to form aqua regia in our beaker and start dissolving our gold. Boiling now for at least a half an hour. I've added multiple shots of nitric acid, and as you can see, there's some undissolved material in here. This is gold from my stock pot. I'm not sure what that's going to be. There's probably some platinum group metals in there with the gold. I'm not going to chase after those few little pieces. I'm going to pull it down off the heat now and let this cool off. I'm adding some ice cubes to our solution here. This will do two things for me. This will cool the solution off and precipitate out any silver chloride that may be present. I'm going to filter our solution now. We've got it nice and cooled off. Got a few granules of undissolved material in there, but I'm not worried about that. It's a little bit on the cloudy side, so what we'll do is pass it back through the same filter a second time. As you can see, there was a little bit of junk in our gold solution. We got that filtered out. Now what we'll do is let's try do this all in one take. I'm gonna get this gold solution transferred into this beaker, and then we're gonna add some sodium metabisulfite and precipitate out our pure gold. Here we go. Let's see if we can do this all in one take. Here's our stump out that we're going to use for the precipitation. Yeah, let's get some spoons of stump out added to the gold solution. Here we go. That's pretty cool looking. I keep forgetting to do this. It's important, especially for people that are just starting out. Make sure to test your solution with some stannous chloride just to verify that you've got gold in solution. It's important to do. You see that by that dark stain there, we've got gold in solution. All right, let's put some more stump out in here and get the rest of this gold precipitated out. I'm going to add another spoon here. That should just about do it. Maybe another half a spoon. Alright, let's do another stannous test. See if we've got everything out of here now. And as you can see, negative stannous test. All the gold is precipitated. So what we'll do is cover it up and just let it settle completely. Alright, this is something I started recently. and I forgot to include it in this one, so we're going to put it in here now. I'm going to set this up on the heat. We're going to bring some heat to our solution and try to boil off the excess SMB SO2 gas that might be in that solution. That only took a few minutes to boil. Now what we'll do is bring it down here and just let it cool and settle completely. I've allowed it to settle overnight. Here's our pure gold powder after the first refining. Looking pretty good. I'm going to pour this waste solution off now into my waste container. I rinsed the gold with a little distilled water, and some of it's staying suspended in that rinse. That's okay. I'm just going to pour it off into my temporary container here. I can see some black looking powder down in there, and it's acting. This came from my stock pot, remember? And it's acting like it's got some platinum group metals still in it. So we're going to have to address that. Here's that little bit of solid material that was left in the bottom of the beaker after we dissolved the gold in aqua regia. And what I'm going to do is just add this now right into my temporary waste container. We're going to dissolve the gold a second time. Drop in a stir bar, add some heat, start stirring, and now I'm going to put a little bit of hydrochloric acid in here. I'm going to add a few drops of sulfuric acid to precipitate out any lead that may be present. Now I'll add some nitric acid to form aqua regia and dissolve the gold a second time. It took less than 5 minutes to dissolve. What we'll do now is set this down, let it cool off, and go from here. Every time we dissolve and reprecipitate, the gold gets cleaner and cleaner. Get this out of the way, and we're going to get set up for the next step in the process. Last time I did the SO2 gas precipitation, I used this piece. It's got a restriction up here in a valve that chokes the flow of gas coming out of the gas generator. So I bought this new piece. It came in today, and we're going to use this for our gas generator today. I think we're ready. I'm going to add some distilled water to dilute our gold solution. Here we go. I'm going to reach back here and start the flow of sulfuric acid down into the sodium metabisulfite, and this will generate SO2 gas, and we're going to precipitate this gold now with some SO2 gas. There goes our color change. Boom. And that was quick. As usual, I forgot to test the solution again with stannous before we started this. I'm gonna get a little bit of our solution on a piece of filter paper. Check it with stannous. Now that the reaction is complete, you can see we got no gold in solution. Everything's been precipitated. I'm going to reach back here and turn the acid flow off. We're going to get our delivery tube out of here. And now what I'll do is I'm going to add some heat to the beaker here and go ahead and boil this now to get some to get the SO2 gas out of our solution. I've had it boiling now for about 10 minutes. It's looking real good. The second refining cleaned it up very nicely. Now what we're going to do is we're going to pour this off into our waste container. Here's a look at the gold. It's looking much better now after that second refining. I'm going to rinse this off with a little bit of distilled water. Oh yeah, that gold looks much better now after that SO2 gas precipitation. Beautiful, very nice. No comparison. No comparison. That cleaned it up perfect. See that beautiful gold powder? It looks gorgeous. What we're going to do is add a little bit of hydrochloric acid to the gold one more time. And we're going to put it up here on the stir plate. And we're going to start the stirring and add some heat. Now look at the gold. It's just beautiful. Nice caramel color. Boiling it in hydrochloric acid has cleaned it up nicely. So now what we're going to do is pour off this hydrochloric acid boil into our waste container. Might be a little bit of gold in solution. That's okay. Now look at the gold. It's getting better and better each time we send it through a different process. Gold looks superb. I'm going to hit it with a little bit more hydrochloric acid. Put it back on the stir plate. We're going to dissolve the gold one more time. This time, though, I'm going to use some 12% hydrogen peroxide, Salon Care 40 volume. I'm going to start adding small doses of this to our beaker here. I'm adding a little bit more hydrochloric acid. Just a little bit. I'm going to measure out another 150 milliliters of Salon Care, 12% hydrogen peroxide. And we'll start adding that right on in. So far I've got about 300 milliliters of hydrogen peroxide in there. This has taken about an hour and 15 minutes and about 320 milliliters of hydrogen peroxide, and I finally got everything to go into solution. So what we'll do now is take this down off the heat and let it cool down, and we'll go from here. Now I'm going to get set up to filter our solution. It probably doesn't even need it, but I'm going to filter it anyway. Now we're going to transfer the solution out of our filter flask and into a clean beaker. I'm filtering the junk out of the oxalic acid solution. It's a saturated solution of oxalic acid. I've got a little left here in the beaker, and I'll dissolve that and save it in a separate container for a future refining. Okay, that wood bleach that I buy at Ace Hardware has got some junk in it, so that's why we want to filter it before we do the reaction. I've got some 10% ammonia here, and we're going to pour some in this beaker and get it ready for use up here to bring the pH up. I need the pH in that oxalic acid to be up around pH of 5. I'm reaching in with a little pH test strip, get the baseline for this material. You can see it's pH of 1. I'm going to pour a little bit of ammonia into our oxalic acid, maybe about 150 milliliters or so. It takes quite a bit of this ammonia to adjust the pH correctly in here. Let's get in here with a pH test strip, see where we're at. We went too far with the ammonia, so now we need to add some oxalic acid. Adding some oxalic acid solution to get the pH back down now. Alright, we're about neutral now. Maybe a little bit more oxalic acid to get it right. Just a little bit more oxalic acid. I need a pH of about 5 here. And that's pretty close. I'm going to pronounce it cured, and we're going to go for the precipitation. All right, here we go. We've got both solutions boiling. Oh, jeez. Okay, a little note to self. Do not spray ice cold water on those saucers. Here we go. We're going to pour some oxalic in and try to do this precipitation without creating another mishap. Here we go. Okay, I'm starting to see a color change in there now. Fairly rapid. I'm going to add a little bit more of the oxalic acid here. There we go. I can see the cloud, or the beautiful gold crystals coming out of solution now. See that? That is gorgeous. Such a beautiful sight, but such a pain in the neck to make it happen. The precipitation took about an hour to complete. There's a little piece of glass in there with the gold, but that's okay. We'll get that out. And we're going to pull this down off the heat now and let it cool off. Pure gold has been allowed to settle. I'm going to reach in here, get a little bit on a piece of filter paper. It's got a little bit of color to it. See that? Oxalic acid will precipitate the gold, but it will not precipitate platinum group metals. If they are in solution, they will stay behind in the solution. I'm going to do a Stannis test on this liquid. And you can see we've got a negative result. There's nothing in solution. Now we're going to pour off the waste solution into our waste container and get our gold out of here. Okay, now we'll rinse this with some distilled water. Now we'll give it another quick boil in some hydrochloric acid. Here's a look at the glass that broke. I sprayed it with ice cold water. It was sitting on top of the boiling gold. This has got a little bit of gold on it, these shards of glass. What I'll do is rinse these down into a beaker and then add this little bit of gold solution to my waste container. I've allowed it to boil for about 5 minutes or so. Now what we're going to do is take off the lid. We're going to pour off this hydrochloric acid boil into the waste container. I'm going to transfer the gold into this smaller beaker. Still some shards of glass in there. I'm going to set the gold aside just for a second, and we're going to get set up to do one more refining, just to make sure we got all the impurities out of here and all the glass fragments. These are chlorine tablets for a swimming pool, and what I'm going to do is grind them up into a fine powder and put them in a gas generator, and we're going to dissolve the gold one more time with chlorine gas. Alright, let's get this in our gas generator now. Okay, I think we're ready to go here. Drop in a stir bar. I'm going to cover this up. And now what we'll do is turn on the stirring. We'll start dripping some acid down into the chlorine gas generator. And we'll try to make some chlorine gas here and get this gold dissolved. Just started the flow of gas. Time right now is 10:30 a.m. So we'll see how long it takes to dissolve the gold. During the middle of the reaction, it used up all of the TCA down in my gas reactor down there. So I had to stop everything and recharge with fresh reagents and put more hydrochloric acid in the addition funnel, Plus I'm going to take a glass rod here and kind of bust these up a little bit before we continue with this. Here we go. I'm going to start the gas flow one more time. Just drip some hydrochloric acid down into the TCA and start producing some more chlorine gas and try to get the rest of this gold to go into solution. Alright, the reaction is still going, and I've used a whole bunch of the acid up in my reactor back here. Try to stick a rod down in here and see if we can stir this up a little bit to get a little bit more reaction going. Uh-oh. How we did it. Bang. Mishap. Just keep going. I had a runaway reaction in my gas generator when I stuck that glass rod down in there. I broke through a layer of reacted TCA that was forming a passive layer to the unreacted TCA in the bottom of the flask. And when I broke through that crust, all the acid sitting on top of that crust crashed through to the bottom, got down in the unreacted TCA, and then spewed out of the spot there, or the spout. I'm just glad I didn't have that the outlet to the gas reactor that's going into my gold. Otherwise I'd have a bunch of TCA in with my gold right now. It's been bubbling chlorine gas for about 3.5 hours. I've got just a tiny bit of gold left down in the bottom of the beaker. You can see it in the back there. And so we're going to call it here. And now what we'll do is add a little bit of heat and try to boil off some of the excess chlorine that's in our solution. I think we've got all the chlorine boiled off now. So what we'll do is we'll pull this down off the heat and let it cool off, and then we'll go from here. Here's a look at all the little shards of glass that were left down in the bottom of the beaker. People may be asking themselves, why is Three Tips doing this over and over? And the answer is, every time that we redissolve the gold and reprecipitate it using a different precipitant, the gold becomes more and more pure with each of those cycles. I'm going to move this out of the way, and what we'll do now is get set up to do another SO2 gas precipitation because it produces the cleanest gold. I've got my SO2 gas generator set up back here, sulfuric acid dripping onto a slurry of sodium metabisulfite. That'll produce SO2 gas. It'll come up through this connection through a tube and bubbles through a sulfuric acid flask to cool and clean the gas as it comes from the gas generator. Then the SO2 gas will travel through this tube and into our gold solution. For this reaction, we need the solution to be dilute, so I'm going to dilute it with some distilled water. I'm going to turn the stir bar on. Now I'll start the flow of sulfuric acid down into the gas generator. It'll react with that SMB and form SO2 gas. Here we go. Alright, here we go with our color change. It's going to be a fast reaction. It's only been going for about a minute. Look at that, it turns almost clear. And we should see the crossover now, and our pure gold will precipitate out. There it goes. That's real time. This is not time lapse. So, SO2 gas precipitation is pretty much complete here. Reach down here and get a little bit of the solution on our filter paper. Test it with stannous. You can see all of the gold is precipitated out of our solution. And turn off the acid flow to the gas generator. Now let's get our delivery tube out of here. Now I'll add some heat and we'll boil the solution, get the gold to settle, and rid it of excess SO2 gas. Gold is settled completely now. It's looking real good. I'm going to pull this down off the heat and let it cool down, and we'll go from here. I'll pour the waste solution off into my waste container, and then I'll give it a couple of rinses with distilled water. And here's a look at the pure gold sponge in the bottom of the beaker. Here's our little 3-tips bar, 999 fine gold. Let's see what we got for a weight on it at this point. We've got 9.7 grams. Started with 10.6 and we're down to 9.7. Now what we're going to have to do is mount this on a chain. I stamped it 0002. This will be the second bar in the pure gold bar necklace series. I've selected an 18K gold box chain. It's 20 inches long, and this is what we'll use to create our necklace with. I don't know if you can see those tags on there. It says 750, which means 18K. Made it. I'll sweep all these shavings into a container here, and we'll add this in with our next batch of carrot scrap. Now we've got our finished bar here. I'm going to get a weight on it before we go any further. It's now 9.5 grams of 999 fine gold. Now let's get a weight on the chain. Chain is 6.2 grams. The hole's too small. Got to drill it out a little bigger. All right, we got it to go through. Beautiful. This is a drop of boric acid that's been dissolved in alcohol. Now I'm adding a dab of solder paste to that area. Now I'm going to put a little piece of solder on there. Now what we'll try to do is use a tiny flame here and solder the piece back on the ring. I'm going to pick the whole thing up here and take it over here, dunk it in the ultrasonic to cool it off, and we'll put it in the basket and clean the entire thing now. Finished necklace on a nice 18K gold box chain, 20 inches long, 1.2 millimeters in thickness. And then I've got my little gold bar attached to it down here. It says 3 tips 999. I found this little jewelry box. It is a used jewelry box. And what we'll do is put the necklace on here, and it will arrive just like that. All right, this will conclude the video. This one was a difficult refine. I've got the necklace made now. I probably won't make too many more of these. It's hard to do. It's not easy, but this will conclude the video. Thank you.